Okay. Stages and tasks. Today I discuss about stages and tasks, right? Yes. In PySpark. Spark features. What are the PySpark features? In-memory computing. Data loads in memory and data processed in the memory. What do you mean by in-memory computing? Data stored in the memory and data processed within the memory, right? Storage and processing both happening within the memory. Lazy evolution means transformations are executed only when actions are performed. Distributed execution we see in Spark. Parallel processing we see in Spark. Resilience feature. Resilience distributed data sets. RTD means what? Resilient distributed data sets. During a fault tolerance, Spark has a feature of regenerating the lost partitions of a RTD. Persistence, making the RTD available in the RAM. Making the RTD available in RAM. Making the RTD available in the RAM, right? And stages and tasks. Last one is stages and tasks. What do you mean by stage and a task? Okay, I'll come back to that stages and task. Two types of transformations. Narrow transformation and wide transformation. This also I'll be discussing. No shuffling of data involved. Narrow transformation means no shuffling of data is involved. Wide transformation of data involved. No shuffling of data. Shuffling of data is involved, right? When we launch a Spark application, what happens internally? When we launch a Spark application, what happens internally? When we submit or launch Spark application to any cluster, then two kinds of programs will be created. When we submit or launch Spark application to any cluster, two kinds, driver program and executor program. Acts as master process, acts as slave process. These are master and slave with respect to Spark application, but not with respect to Spark cluster. This driver and executor, these are master and slave with respect to Spark application, not with respect to cluster. With respect to Spark cluster, if it is yarn cluster, resource manager is the master. Slave is node manager. Port number where it is running 88088. And if it is Spark standalone cluster, Spark master, Spark worker. The port number of Spark master is 7066. Stages and tasks I'm supposed to discuss, right? They belongs to drivers and executors. Driver and executors. A Spark application is submitted to a yarn cluster. When a Spark application is submitted to a yarn cluster, then we require some resources for running the application in slave nodes. We require some resources for running the application in slave nodes. such as memory and processor, such as memory and processor. These resources are allocated by node manager of each node. You know already about yarn, right? What is yarn components, yarn master, slaves, which are going to be stored at the master and slave. Who allocates resources? The resources are allocated by node manager of each node. The resources are allocated by node manager of each node. Each node has got a node manager. That node manager is allocates. Node manager maintains the entire node. A resource manager, right, maintains the entire cluster. Resource manager maintains the entire cluster. Node manager maintains the entire node. When Spark application submitted to resource manager, see, in data node 1, data node 2, data node 3. Slave 1, slave 2, slave 3. Slave 1, slave 2, and slave 3. Data node 1, data node 2, and data node 3. Node manager 1, node manager 2, node manager 3. Block 1, block 2, and block 3. 3 blocks. So any file divided into blocks, right? Blocks means partitions. In Spark, we say like partitions, partition 1, partition 2, and partition 3. If 3 blocks, 3 partitions. 10 blocks, 10 partitions. All the node managers will be under the resource manager. All the node managers will be under the resource manager. Blocks are stored in the data nodes. Generally, blocks partitions are created by allocating the resources by node manager. From blocks partitions, from blocks, partitions are created. Generally, partitions need to be processed with a business logic. Generally, partitions need to be processed with a business logic. We perform operations over the partitions or data. We perform operations over the partitions or data. Who supplies the logic or operations to be performed on the data? Okay, 1 second. When we launch a Spark application, Driver is created. Driver is created. Data node 1, data node 2, data node 3. P1 partition, P2 partition, P3 partition. Whenever you launch a Spark application, driver program is created. One more thing is executor is created. So who provides, so I'm providing some logic. Who provides logic? Partition 1 to partition 2 and partition 3. Driver programs provides the logic. Who provides the logic to each partitions? Driver. Who executes the partitions? Execution of this partition 1 along with the provided logic is carried out by a program called executor. Execution of the partition with the logic provided is taken care by a program called executor. Here executor 2 will take care of this partition 2. It's going to execute the partition 2 along with the provided logic. Executor 3. So now try to understand what is driver and who provides the logic? Driver. And execution of the partition along with the provided logic is taken care by a program called executor. Now observe here. Generally, partitions need to be processed with some logic, business logic. We perform operations over the partitions or data. We perform operations over the partitions or data. Who supplies the logic or operations to be performed? Driver. See, clearly check this. Whenever we launch Spark application, creates driver program. So P1, P2, P3 partitions. Node manager 1, node manager 2, node manager 3. Data node 1, data node 3. If 3 data nodes, 3 node managers, 3 partitions are stored. This driver program supplies logic to P1, supplies logic to P2, and supplies logic to P3. Executor 1, executor 2, executor 3. 3 executors. Spark applications creates a driver program. Driver program supplies logic or operations to each partitions of slave node. The execution of the partition with the provided logic is carried out by a program called as executor. The execution of the partition with the provided logic is carried out by a program called as executor. Executor program will process the data, partition data, based on the logic provided. Executor program will process the partition data based on the logic provided. If 3 partitions, then 3 executor programs will run. If 3 partitions, 3 executor programs will run. If 10 partitions, Number of executors equal to number of partitions. How many executors means depends on number of partitions.
These partitions get created automatically or we need to create?
So whenever we load data, we can also provide the number of partitions.
Okay.
Default, it will be you will be getting the partitions based on the blocks.
Okay. So if we even don't specify, then still the partition will happen, right?
Partition, even if you won't specify, partitions will be created. So you can say get num partitions to the number of partitions.
Okay. Okay.
Okay. So so number of executors always depends on the number of partitions. All these executors will be under the control of driver. That's why driver is the master of Spark application. Executor is the slave of Spark application. Now, what do you mean by stages and tasks, right? Still, we didn't discuss about stages and tasks. Task means nothing but a partition under execution. What is it? A partition under execution. It is a state. Task is just a state. Partition under execution. If it is a state of execution of a partition, it is the state of execution of a partition, but it is not a process. It's not a process, it's a state only, right? Execution of a partition. Number of tasks equal to number of partitions. Number of tasks equal to number of partitions equal to number of executors. How many? So I can say, right? How many partitions? Those many executors. How many partitions means those many tasks, right? If there are 10 partitions means 10 tasks and 10 executors required for that. 10 partitions, 10. Just a second.
Hello? Hello?
Sorry. Fine. So a task is nothing but a partition under execution. It's a state. It is state of execution of what it is not a process. So if there are 10 partitions, 10 tasks means 10 partitions means executing the 10 partitions with 10 tasks. 20 partitions, 20 tasks. To execute those partitions, we require executors. So execution of the partitions with the provided logic is taken care by a program called executors. Understood what is a task? Number of partitions, nothing but number of tasks. Stages, now if you want understand the stages, right? If you want understanding the stages. Observe these stages and tasks, right? R1 is an RTD. How you got this RTD? sc.text file, loading that HDFS file, RTD1 is created. Okay, think that you got 3 partitions, P1, P2, P3. How you got this R2? RTD2. On the R1, if you have performed a transformation T1, some transformation, filtering or any of, you got RTD2. On this R1, the partitions, R1 has got 3 partitions, P1, P2, P3. On this, you have performed T1 transformation. Yes. We have performed T1 party, okay. Transformation, right? R2 is created. R2 is a narrow transformation. Why we are saying it as narrow transformation? Data is coming from P1 to P1, P2 to P2, P2 to P3, right? It's a narrow transformation. Data is not shuffled. No shuffling here. On the R2, I performed one more transformation. On R2, I performed one more transformation, T2. R3 is created. Yes, on this P1, P2, P3, again T2 transformation is applied. You got R3, RTD3. From P1 to P1, P2 to P2, P3 to P3. Now on this R3, T3 transformation applied. On this R3, T3 transformation applied. Once it is applied, data is shuffled from P1 to P2, P1 to P3, P2 to P1, P2 to P3, P3 to P2. In this way, data is shuffled. So whenever data is shuffled, whenever we apply wide transformation, then only the data is shuffled. Here data gets shuffled. Whenever data is shuffled, means up to here one stage is created. Up to here one stage is created. From when that shuffling is happening, from here a new stage. From here a new stage, you are going to have a new stage. Yes, shuffling happens. Now, whenever wire transformation is applied, encountered, then a new stage is created. Now, again, on this R4, I'm applying transformation T4. It's a narrow transformation. So from P1 to P1, P2 to P3, P2 to P3, right? Yes. Now, P1 to P1, P2 to P2, P3 to P3. Okay, narrow transformation applied. Okay, up to okay. Now immediately on the R5, I have applied transformation T5. Shuffling is happening. Again, data is getting shuffled. Data is shuffled means again a new stage is created. Whenever data is shuffled, a new stage will be created. Up to here, it is stage 2. R5 dot T5, R6 is created. It's a wide transformation, new stage. Understand here? P1 to P1, P1. See this P1 to P1, again P1 to P1. See in the first 3 cases, narrow transformation. But whenever on this R3, T3 is applied, R4 RTD is created. Wide transformation, data is shuffled. Whenever data is shuffled means a new stage will be created from there. Until the next shuffling happens, it will be within the same stage. So up to here, it will be within the same stage. Now from here onwards, a new stage, right? So in a simple way, when a wide transformation is applied, then a new stage will be created. When a wide transformation applied, a new stage will be created. Up to here, stage 1. Can I say number of stages equal to number of wide transformations? Observe here how many stages. Up to here, stage 1. Wide transformation applied. So stage 2. Again, one more wide transformation. That is the stage 2 closed. Again, stage 3. So here, totally how many stages? 3 stages. How many wide transformations? Understand here? Can I say number of wide transformations equal to number of stages? Here, how many wide transformation? 1 and 2 only. But here, how many stages? 3 stages. Up to here, stage 1. Whenever wide transformation is encountered, up to that stage 1. From there onwards, stage 2. Again, one more wide transformation. Up to here, it is stage 2. From here onwards, stage 3. Means totally 3 stages. But how many wide transformations? 2 wide transformation. Number of stages are 3. So what is the equation? Number of stages equal to, so number, okay, just observe this is
Number of stage minus 1 is equal to
number of stages equal to number of wide transformations plus 1.
plus 1. Yep.
How many stages means how many wide transformations? 2. So in the above example, number of wide transformations are 2. So number of stages equal to wide transformation plus 1. 2 plus 1, 3 stages, stage 1, 2, and 3. Here data is shuffled for 2 times. Here data is shuffled for 2 times. So number of stages is 3. If data is shuffled for 4 times, number of stages will be 5. Data is shuffled for 2 times, number of stages is 3. If data is shuffled for 4 times, number of stages equal to 5. If 5 stages are created, how many wide transformations? 4. If 5 stages are created means number of wide transformations will be 4. Now try to say me what is a stage. Now try to say me what is a stage. Task means a partition under execution. What is a stage? collection of all RTDs or transformations which doesn't involve shuffling. Collection of all RTDs or transformations which doesn't is a collection of all RTDs or transformations which doesn't involve shuffling. One shuffling involved means a new stage will be created. Once shuffling is involved means new stage will be created. From RTD to RTD, if data is flowing without shuffling, from RTD to RTD, if data is flowing without shuffling, it is a stage. Means from first RTD to second RTD to third RTD, same from one partition to another. If data is flowing, right, it is a stage. If shuffling is involved, then a new stage is created. If shuffling is involved, a new stage is created, right? Relation between stage and a task. Understand the relation between a stage and a task. RTD, three partitions. RTD has got three partitions. RTD has got three partitions. P1, P2 into P3. All this P1, P2, and P3, you are applying transformation 1 applied. Transformation 1 applied on each partition. Transformation 1 applied on each partition. So RTD divided into partitions. On the partitions, transformation applied. So executed. Partition plus transformation. Executor means partition plus transformation. The partition with the provided transformation logic is taken care by executor. Three partitions, three executors means three tasks. Okay, RTD1, P1, P2, and P3, three partitions. RTD1 divided into three partitions, P1, P2, and P3. So B1, B2, B3, from three blocks, three partitions created. On these three partitions, you applied a transformations. For these three partitions, three executors means three tasks. Narrow transformation only as data from P1 to P1, P2 to P2, P3 to P3. RTD2 RTD2, right? Yes. Three partitions, you applied transformation to RTD3 is created. Here, three partitions means three executors, three tasks, stage one. Here also from P1 to P1, P2 to P3, P2 to P. Yes, data is moving. But on RTD3, I'm applying a transformation. On RTD3, three partitions, I'm applying a transformations. Here, three executors, three tasks. But here, the output RTD4. But here, shuffling happens within the partitions. Shuffling happens within the partitions. Here, up to here, it is stage one. Up to here, here, up to here, it is stage one. From here onwards, right? Stage two starts. Until when stage two continues, until another white transformation is encountered, until then, stage two continues. RTD4, P1, P2, P3, P1, P2, P3, you are applying some kind of transformations. Three executors, three tasks. From P1 to P1, P2 to P2, P3 to P3. Narrow transformation applied. Narrow transformation applied. Okay, still on RTD5, you applied a transformation T5. So narrow transformations. But on RTD6, you have applied a transformation, right? On RTD6, you applied a transformations. Shuffling happens. Here, shuffling happens. Whenever shuffling happens, stage two ends and stage three starts. Stage two ends, stage three starts. Okay, fine. Understood, right, everyone? Stage one, stage two, stage three. So how many white transformations are applied here? In this example, how many white transformations are applied? Two white transformations, right? Here is one white transformation. Here is one white transformation. So number of stages will be three. Understood what is stages and what do you mean by tasks, everyone? Hello. Stages and tasks. Driver and executor. Whenever you launch a Spark application, driver program. Executors means execution of the partition along with the logic provided. Right? As long as the transformations are narrow, they fall in the same stage. They fall within the same stage. Whenever shuffling happens, a new stage is created. Execution of sequence of narrow transformation. Stage is nothing but one more definition you can say. Execution of sequence of narrow transformations. New stage gets created for a wide transformation. Executor means program which process a partition. Task, a partition under execution, a partition under execution. Driver which monitors the executors. Who monitors the executors? Driver. That is whether they are killed or running. Driver won't process the partitions. Who process the partitions? Only executors process the partitions. If number of white transformations 4 means number of stages will be 5. If number of stages 4 means number of white transformations will be 3. If number of partitions 4 means number of executors equal to 4. Number of partitions 4, the number of tasks also 4. Number of executors 4, the number of tasks will be 4. Number of tasks, number of executors 3 means number of drivers 1 only. Only one driver program, right? For the entire thing. So in this, you need to clearly understand narrow transformation. What is a narrow transformation, everyone? Hello? What is a narrow transformation which does not involve shuffling? What is wide transformation which involves shuffling? Now, what is a driver? Whenever we launch a Spark application, driver program, two programs are created, driver program is created. Yes. Now, reading and writing into multiple file formats. Working with different file formats. Reading different file formats in PySpark. So just you can work on this CSV file, JSON file, Parquet file, ORC file, Avro file. CSV file means, okay, from PySpark import Spark session. Spark session.builder.app name, demo application or get or create. A Spark session is created. Spark session object is created. One Spark session object is created, right? We can say spark.read.format CSV option infer schema true dot option header true. Reading a CSV file and creating a data frame, right? And how we are creating the path, file path, HDFS localhost 9000 PySpark. So here PySpark 6:30 p.m. is there, right? In that emp1.csv is available. The last week we have created one emp1.csv. From that df.show. Data frame is created. Writing into a CSV file. Writing into a CSV file, creating a CSV from a data frame. Data frame dot write dot option header true dot CSV. So writing into a CSV file, right? Yes. Into which file you want to write? HDFS localhost PySpark 6:30 p.m. we can say right. CSV1. CSV1 means a folder. So once data frame is created, data frame dot write dot option header true dot CSV where you want to write that path we need to specify. Okay. Okay. So once data frame is created, data frame dot write dot option, just provide that header I want and dot CSV right there. This is the path. Now if you go and check, right? If you go and check in that tab, CSV1 is a folder. In that folder, you will see like part file, part -000. This is the file name by default. You will get this file name dot CSV. You will get this file name dot CSV. If we say cat command, you can see what data is present in there. What data is present. Now, similarly for JS1 file also, right? We already discussed about CSV JS1. Spark session creation, file path where that file is available, and read dot format the JS1, spark dot read dot format JS1 format, right? Load file path. Spark dot read dot format JS1 format. Spark dot read dot format JSON load that file path. Okay, from a JSON file, how to create a data frame, but from data frame, how to write, how to create a data frame dot write dot JSON, give the file path. That's it. Is the folder with dot JSON file gets created. And Parquet file also, it is a column oriented binary file format. Column oriented binary file format used for large scale queries. So here also, right, once the Spark session is created, the file path where the Parquet file is available, the file path you can provide, and spark.read.format, the Parquet format dot load data frame gets created. Now writing into a Parquet file also, tf.write.parquet, give the path of that Parquet file. ORC, optimized row columnar, ORC. Once Spark session is created, right? Once the Spark session is created, so the file path where that ORC file is from that ORC file. Okay. Spark.read.format, which format? ORC. Dot load the file path. Load the file path. Data frame dot show. Now writing into a ORC file. Creating a ORC. Creating a ORC file from a data frame. Data frame dot write ORC. data frame dot write Parquet, data frame dot write JSON, data frame dot write CSV. You want to write into the different files. Any data frame you can, from a data frame you can create any file, CSV file, JSON file, ORC file, Parquet file, Avro file, and give the path, right, where that is available, right? Yes. Yeah, fine. Writing into ORC file. Now Avro file, right? Yes. From PySpark.sql, creating Spark session. See here, importing the Spark session, creating Spark session. Once the Spark session object is created, using that Spark session object, read format, Avro file, load the file path where it is available, right? In the HDFS, where it is available, that path you provide. Then data frame gets created directly. So data frame directly gets created from a CSV file, from a JSON file, from a database table I showed you, and from Avro file, from Pocket file, from ORC file, right? DF dot. Now DF dot write dot format, not DF dot write dot format. Which format? Avro format. Dot save. Give that where you want to save it, right? Give that path where to save it. Next is okay. I will show you how to work with PySpark and Pandas. Python Pandas are there, right? How we can for working with PySpark and Pandas. Some other functions are there. Next, how to perform Spark submit. Spark submit. Fine. So check with these examples, right? Yes. That just I'll forward you these notes once. Check with this. That tomorrow session I'll be showing you more on this, right? Spark submit and PySpark and Pandas. Okay. Tomorrow, as I said, those who are attending like HBase class, same timing as today's, right? Same timings of today. HBase and PySpark both will be there, right?